Assalamualaikum and hello to everyone. My name is Faris bin Ahmad Taufiq Nesri with matrix ID 2019-250508 from class J4EM 103E. So I'm going to talk about the discussion from doing this torsion test. So the result from this experiment is quite different from the reference. This is because while doing this experiment, error will occur. For example, manual calculation can lead to slight error if not cautious. In other case, equipment can also lead to error in the data analysis when not adjusted properly. And also, surrounding will also affect the result obtained, as some material will react differently in different temperature. So the behavior of the material is that they behave differently when in torque. The material will react elastically, plastically, and fracture. The material will fracture when it can no longer hold the torque applied. The Hooke's law is applied for this experiment. So this is because the strain and stress value is proportional. The material will only obey Hooke's law only up to a certain limit, that is, the stress and strain is proportional. So from the experiment we can get that steel is ductile, and the surface appearance of steel that is ductile material is dull and fibrous, while brass have a surface of brittle. Brittle fracture are characterized as having little or no plastic deformation prior to failure. Brittle fracture also have a distinctive fracture surface. The fracture surface of a brittle failure is usually reasonably smooth. The crack propagates through the material by a process called cleavage. So, in the difference between solid bar and hollow bar is that hollow bar will be able to resist more torque. This is because hollow bar shaft has a larger radius and will get lesser stress. Higher radius will carry higher amount of torque.
Discussion 1. From the result of the experiment, the modulus of rigidity for the experimental value is 8.09 exponent 10, while the reference value is 0.75 exponent 10. The value is pretty far from the reference value and led to 4.39% error. From the Poisson's ratio value, the experimental value is 0.2361 and reference value is 0.3 and led to 21.3% error. We also obtained 4.02 exponent -3 shear strain value and 3.30 exponent 8 shear stress value. While conducting the experiment and calculating the result, there are a lot of errors that possible. When calculate the value by manually, the calculation may not be perfect and there are possibly a miscalculation when inserting the value in the equation. The condition of the surrounding can also affect the result while conducting the experiment. The machine or apparatus also may affect the value. Discussion 2. The behavior of the material will act differently and twist along the axis of the rod. The elastically, plastically, and fracture will react to the material. The material will fracture when it can no longer hold the torque applied. As torque increases, the angle of twist will increase in an exponential pattern. Discussion 3. Yes, the Hooke's law for shearing stress and strain valid because stress and strain are proportional in the plotted graph. For discussion 4, a ductile failure shows the appearance of yielding and plastic deformation leading up to the final failure. The fracture appearance is rough and torn. Brittle failure is considered when a specific test specimen breaks suddenly without deforming and straining. Brittle failure are characterized as having little or no plastic deformation prior to failure. The fracture surface of a brittle failure is usually reasonably smooth. Test specimen brass is more ductile in nature compared to carbon steel, which will make the failure under torsion a ductile failure. For discussion 5, A hollow bar will be able to resist more torque than a solid bar. The reason of this because the diameter of the hollow bar is more and require more space. Hollow bar also having more polar moment of inertia. Thus, they can transmit more torque than solid bar.
The result from this experiment is a little bit different from the standard value. The value of modulus of rigidity is 8.09 times 10 power of 10 and 75 times 10 power of 10 for the standard value. This is 4.39% error. Meanwhile, for the Poisson ratio, the experiment result is 0.2361, while the reference is 0.3, including it with 21.3% error. Lastly, the experiment value for the shear stress and shear strain is 3.30 times 10 power of 8 and 4.02 times 10 power of negative 3. Error will occur in every experiment. The manual reading sometimes a little bit off, or the surrounding factor that make the experiment not in the perfect condition, and many more error that can happen. The material will behave elastically, plastically, and lastly fracture. The material will fracture when it can no longer hold the pressure applied. Yes, it is valid because a proportional increase between stress and strain was achieved when the shear stress and strain plotted in the graph. The appearance of the fracture surface is dull and fibrous. Brittle failure is when a test specimen breaks without deforming and straining. A hollow bar able to resist more torque due to the larger radius. The higher their radius, it can resist more torque.
So in conclusion, by doing torsion tests, we can obtain and determine the behavior of a material produced when twisted or under torsional forces because of applied moments that causes shear stress about the axis. The understanding of how different material and cross-section behave under an axial tensile loading was achieved. The stress-strain relationship and comparison of mechanical properties of various materials and cross-section was obtained, and the mechanical properties of the sample was obtained. So thank you. That's all from me.
For the conclusion, to sum up, this experiment can help us to gain the value to calculate the modulus of rigidity, maximum shearing stress, maximum shearing strain, Poisson's ratio for each tested specimen, and it was achieved successfully. This value can be compared to the reference value, so the accuracy of the experiment can be decided. Even though there are slightly error in the value while conducting the experiment, but the experiment value is actually close to the reference value. By conducting the torsion test, we also can study the linearly elastic behavior of the tested specimen under torsion. The relationship between torsional load and angle of twist, and hence obtain the shear modulus was achieved.
For conclusion, in this experiment, many values can be found such as shear stress, shear strain, angle of twist, modulus of rigidity, and maximum shear stress and strain. Compare the experimental value and the standard value to determine the accuracy. The objective of this experiment, which is examine the elastic behavior of the tested specimen under torsion and obtain the relationship between torsion load and angle of twin, and next obtain the shear modulus achieved.